So we have done up to current density, electric current. How we'll find electric current in different conductor, maybe metallic conductor, different electrolyte, and semiconductor. Now, drift velocity. What is drift velocity? So what happens in case of metallic conductor? Metallic conductors have got so many free electrons. Well, this is Y. So it has got atoms. They are arranged for particular way. These atoms are arranged in a particular pattern. Now each atom has got free electron. Maybe 1 electron, maybe 2 electron, depending on what type of material we are using. For example, in case of copper, each atom has got 1 free electron. If you are considering aluminum, each atom has got 3 free electrons. So that will depend on which material we are using. So suppose each atom has got 1 free electron. They are at different sorry. Now, when no potential difference is maintained, what will be? These electrons are moving in haphazard way. One are going this side, one is going this side, other is going this side. So they are moving in haphazard way. As a result, we are not getting any current. When there will be flow of electron, then only electric current will be there. Flow of electron means all the electrons are moving in same direction, like river is flowing. So all water molecule is moving in same direction. When will this happen? So if we maintain a potential difference. So if we maintain a potential difference, suppose that positive terminal is that side. So each electron will start moving. All the electrons will experience a force of attraction. So all will start moving. So they will experience force in this direction. So each starts moving towards the positive terminal. During this movement, what will be? The electrons will collide with each other, or it will collide with core atom. Core atom means leaving the electron, whatever we are considering, that is core atom. So this circle we are saying this is core atom. For example, this Cu plus ion, and this small dot we are saying free electron. So when this electron collide with other electron, there is no loss of energy. Only energy will be shared. Okay, from one electron it is going to other electron, or from second it is coming to first, maybe like that. So energy will not be lost. That is, it will not be transformed into any other form. But once it collides with atom, then what will be? Its whole energy will be transferred. Like a small particle is, suppose you are a ball of mud is striking the wall. What will happen? The mud will drop at that place only. That is, whatever energy or whatever kinetic energy of that ball was having, it is transferred to the wall, but there will be no effect on the wall. So finally, what will be? That energy is transmitted or transformed in the form of heat only. So during this, as a result, what will be? If we find the average velocity of electron during this motion from here to here, what is the average velocity of electron? That will be very less. That's why we say electrons are drifting. And this average velocity of electron within the conductor we call drift velocity. Understood? What is drift velocity? So the value of this drift velocity is of the order of millimeter per second. So suppose this 5 meter long you are taking, then how much time it will take to cross this electron from here to here? Maybe 1 day. But when you are putting the switch on, if the same electron is going from the switch to the fan, what will be? When you are putting it on now, fan will start moving after 5-6 hours. But that is not the case. So what is happening? Actually, when we are putting the switch on, the energy is transmitted, and that is transmission is very fast, like the electromagnetic wave, the speed of electromagnetic wave. That's why when you put it on, light is glowing or fan starts working. But actual movement of the electron within the conductor is of the order of millimeter per second, and that speed only we call drift velocity. So drift velocity is the average speed or average velocity of free electrons, you can say free electrons within the conductor and the potential difference is maintained. So if a potential difference is maintained, whatever the value of velocity of electron will be, is what clear today? Yes?
Not much, but it is better than yesterday. So we can understand. We can understand.
So this average velocity we call drift velocity, and symbol we are giving Vd. Now suppose this conductor has got n electrons and length of this conductor is n. Area of cross section is A. Current passing through this is I. This may be same wire, whatever wire is here, same we are considering. We have just elongated, means we have magnified that figure. So the same current is passing through this wire also. So total number of free electrons we are saying, total number of free electrons. Suppose we are giving the symbol capital N. This is number of electron per unit volume, and A into N. N is number of free electrons per unit volume. This will be different for different conductor. If you are taking copper, number of free electrons per unit volume is different. If you are taking silver, it is different. So this N will be different. Naturally, this N will depend on this N as well as the dimension of this conductor. If you are considering larger length, now suppose during time interval T, this electron has reached to this, oh sorry, from this side. No, electron is going this way. Okay, correct. This electron has reached to this place. So what is this average speed? L by T. So let after time T, so when this electron has crossed this point, what does it mean? All the electrons have moved. So this electron reached here means all the electron has moved. Now fresh electron will come from this side. This electron is moving this way. From here electron is coming fresh. So all the places are occupied by the electrons. This way it keep on circulating. Electrons are not lost during this flow of current or during the electric current. Number of electrons is not lost. Energy will be lost. Or lost means in the sense the energy is transformed into some other form. But number of electrons will remain same. That is conserved. If 100 electron is reaching to this place, 100 fresh electron will come from this place, from the negative terminal of the battery. Okay. So during this interval, what will be total number of electrons? That is N electrons had moved from this end to this end. So during time T, n electrons. That is total number of electrons. Has crossed the conductor. So this electron has come to this place. That is during this time, this electron has crossed. So this drift velocity we have to find, that is L over T we have to find. Now what is the current? So this I average will become N E over T. Yes?
Yes, sir.
And this VD will be L by T. Because during this time, this electron has reached from here to here. So average velocity of electron will be this by this. Got? So how these two are related? Here, from here we can find the value of T and substitute here, or anyhow. So from these two relations, what we are getting? So this I average will become N E, and in place of T we will write L by VD. In place of this capital N, we will write N A L. Yes. Yes. Any confusion?
No, sir.
No, sir.
So this VD is, this L will be cancelled. So it is I average over N A E. Now I by A, J. So this drift velocity is J over N E. Drift velocity velocity is a vector quantity, current density is also a vector quantity. Yes, got. Now, this one sometime it is asked what will happen to the drift velocity if this is changed. Maybe conductor is increased, the length of the conductor is increased, batteries potential difference is changed. So, what will be the effect on that? Now, in class 10, we have seen the resistance. Same figure was there. In that case, what will happen? We'll have some idea, then only we'll come to that point. So, what will be the resistance is what? The property due to which conductor opposes the flow of electron. So, this resistance of conductor is R was rho L over A. This is all we have done class 10. That is, resistance is directly proportional to length. If you increase the length, naturally, number of collision will be more. When the same electron passes from this end to that end, number of collision will be more. Naturally, opposing power will be more. But if you increase the area of cross section, suppose in place of this, if you are taking this much area, and for the same current, that is same number of electrons will flow. So 5 electrons are flowing in this area or 5 electrons are flowing in this area. Naturally, less chance of collision will be there. Suppose one person has to cross the big crowd. Naturally, more number of collision will be there. If crowd is less, one person is standing here, other is here, other is here, so then he can cross easily without suffering any collision, without having any collision. So if area of cross section is more, naturally number of collision will be less. So resistance will also be less. That's why it is directly proportional to L, inversely proportional to A, and this is what we call this. What we call this? Rho. Gone.
Resistivity.
Resistivity, sir.
So, rho is resistivity or specific resistance. This will depend only on
Nature of material.
nature of material and temperature also. So this rho depend Now inverse of resistance, what we call?
Conductance.
Conductor. What we call 1 by rho?
Conductivity.
Conductivity. So sigma we call specific conductance. Or conductivity. Unit of rho? Ohm, meter square by meter. Ohm, and this unit of sigma, ohm inverse, meter inverse. 7 per meter. Other units may be ohm, centimeter, ohm, millimeter, that is also used. If length is in centimeter, area of cross section is in centimeter square, it will come ohm centimeter. If length you are taking millimeter, area of cross section you are taking millimeter square, resistivity will come ohm millimeter. Now Ohm's law. What is said? Ohm's law. So Ohm's law says this V is IR. I is the current passing through conductor, R is the resistance of the conductor, V is the potential difference. Now, how this drift velocity, sometimes you will be asked, how it depend on V, potential difference, how it depend on length, so now you see this VD is J over NE or I over ANE. In place of this I, we are writing V by R. So this is V by rho N E and. So how it depend on potential difference and length? If you are not changing the current, it will not depend on the length also. Means if you are not changing the potential difference, you will not change the length also. So this depend on the nature of material. This also depend on the nature of material. No? This is electron, charge of electron. So it will depend on V and L. Now this V by L, if electric field is uniform, then what will be?
Electric field.
V by L is E. So this drift velocity is okay. 1 by rho, we can write sigma. VD and E. VD and E is what? J. Oh, sigma is here. This sometimes we call Ohm's law in vector form. Current density sigma E. Current density and electric field will always be same direction. So based on this one, frequently one mass question is asked, what will be the effect on drift velocity when potential difference across the wire is doubled without changing its length? Or what will happen to the drift velocity if its length is doubled without changing the potential difference or without changing the source? Then from here only we will come to know what is happening. What will happen if area of cross section is made double without changing potential difference or length? It does not depend on area of cross section then in that case. So depending on what is constant, you will compare one relation here and one relation is this one. So depending on what is asked, if current is same and then area of cross section is doubled, naturally J will become less. J less means VD will be less. Okay, so we'll leave up to here. So these all relations you have to keep in mind while solving the numerical. Yes. Shall we leave up to here?
Yes.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay. So today your junior is getting result. So pray for them.
Yes, sir.
And your senior also getting result. So pray for them also. Okay. Thank you.
Thank you, sir.